Video, I'm going to strengthen your knowledge on the t-test and also show you a matched t-test. This video is going to revolve around a sports question involving the NFL's New England Patriots, who in 2015, during a playoff game, were accused and found guilty of using underinflated footballs. Because my brother's a New England Patriots fan, I'm going to actually try to be very generous here with the New England Patriots in terms of the science behind the illegal practices that they were accused of doing. So if you could pause the video to read the opening paragraph, that would help. Or if you have the worksheet yourself, try the worksheet ahead of time. Try these questions ahead of time and see if you can get the same answers that I did. After these two questions, there'll be two other questions that will follow up on the deflation of footballs and how much impact they may or may not have on the game of football. So having read the question, the NFL rulebook says that if the balls are inflated at 12.5 pounds, that's the lowest allowable pounds per square inch for the NFL rulebook. As per the NFL rulebook, I'm going to use some physics equations here and some science knowledge to translate that 12.5 pounds on a regular sort of day to the poor weather that they were playing in New England in that day in the Boston area, with the colder temperatures and the fact that these were measured perhaps at the beginning of the game, and the measurements around halftime could have possibly deflated the footballs slightly through their use and through the temperatures. So using that number there as our guide, the referees measured 11 footballs, or one referee measured 11 footballs during the halftime. And if we're saying that the true average should have been 11.42 at the very least, the question's asking, do these results right here indicate that the New England Patriots were playing with significantly lower pounds per square inch in their football? So whether or not you're a football fan, try to, if you're not a big fan of sports, just ignore the application of the fact that this is in the sports world, but of course enjoy it if sports is your thing. Let's start off with the all-important first step here, making sure that you write correct hypothesis statements to begin with. So the null hypothesis would be that the true average is said to be 11.42. Whenever you're doing a hypothesis test, you never discuss the sample in the opening step. The only number you're going to use is a number that actually comes from the population. And we're told that the footballs should be at 11.42 as their average. So that would be our null hypothesis. As far as the alternative hypothesis, it'll also have the same ingredient. In this case, it's the average. It'll also have the same number here, the parameter that comes from the population. The only difference is the null hypothesis will have an equal sign, and this will have something other than an equal sign. With the way the question's worded, we're wondering if these measurements showed a significantly lower pounds per square inch. We're told it should be 11.42, but we're believing that the true average is probably less than 11.42. And if you take a look at these examples here, only a few of them are above 11.42. So there's only 4 of the footballs of the 11 that qualified to even make that minimum mark of 11.42. And if you compare that to the 12.5, which it should have been, all of the balls were actually below that mark. The second step is to name the test that you're using. Since this question is revolving around averages and we do not have the standard deviation from all footballs, we just have a standard deviation that could be gained from the list here. We're going to be using a t-test. Was it a simple random sample of footballs? No. Is our sample size large enough? Actually, no. We've got a sample size of 11 footballs measured when it should be greater than or equal to 30. Now, in cases where the sample size is smaller than 30, and if you have all the data, one thing you can do is actually put the data into a calculator, which I did, and you probably will do as well, and graph the box and whisker graph. And what you're looking for there, you're looking for outliers or graphs that are non-symmetric. If either of those two things are happening, then the sample size being less than 30 is still a problem. But in this case, it comes out pretty good. Pretty good for us, a good result. The graph is somewhat symmetric. Here's where the median is, somewhat symmetric, and there's no outliers, which is important to see. So even though the sample size is not greater than or equal to 30, that's not going to cause a major malfunction when it comes to our conclusions. The one last thing we want to do before we actually leave the second step is something that I often forget to do, even after doing this for many years, is set a significance level. How low is too low? And usually, if it's not given in the question, usually we'll choose 5% or 1% to represent a small probability. And that's going to be a number that we use in the fourth step. We're going to be comparing our p-value to that number. All right, so on to the next step. Now that you've identified that it's going to be a t-test, we're going to need some ingredients. We're going to need the sample average. We're going to need the true average. We're going to need a standard deviation from the sample and the sample size. And all those numbers can be gained by just simply going to your calculator as shown and going to stat and then edit and then typing in the 11 numbers. Here I have them in list number 1. If you press stat, calculate, and 1var stats, it'll bring up the statistics that are important to us. Again, the sample average, the sample standard deviation, and the sample size are 3 numbers that we'll definitely need. Stay away from sigma. That will not be any standard deviation that we'll use in the course, but in this case, the standard deviation we need is at 0.460. So going back to the worksheet here, you can see that I plugged all 4 of those numbers in to arrive at my t-score, or my t-value. And that number right there is the second most important number on the page, I'd say. One reason why it's so very important is it actually took 4 pieces of information and turned it into just one solid number. Now it's on to graphing this, but not on a normal curve, on a t-curve. And the difference between a normal curve and a t-curve is sometimes very, very little in terms of the difference. This is one particular t-curve that has a degree of freedom of 10. Remember, our degree of freedom is necessary if you're going to use the calculator to punch out the p-value. So the degree of freedom is n minus 1. Since n is 11, our degree of freedom is 10. And that'll be important as we move forward. So here we have a t-curve. And you can see that on the t-curve I placed our t-value. Kind of makes sense. Going back to our alternative hypothesis, you can see that very clearly, that on the alternative hypothesis, it's a less than symbol. So we are going to shade to the left. Yeah, how rare would it be for our sample of footballs to be this far off its mark or worse? So that's going to be our p-value that we're interested in figuring out. And to do that, remember we're not on a normal curve, we're actually on a t-curve. So we're going to be using the command tcdf on the calculator. And tcdf is actually asking for 3 numbers. The first 2 numbers is the range. So we're going from negative, well, it could be negative 2,000, negative 1,000. Typically you pick something very, very low to negative 2. And then the last number would be, so it's the min, the max, and our shaded zone, and then the degree of freedom, which would be 10. So I'll do that right now. So go to stat, or go to second, vars, and find tcdf, and type in -1000 to -1.44, and the degree of freedom was 10. Uh-oh. Oh, there we go. So 0.09. So we're getting something that's not really low amount of probability, about 9% chance. So there's a 9% chance that we would get a result this rare or worse. So now it comes to summarizing what that all means in the fourth step. So our p-value, we're going to compare that to the significance level, and we're just going to simply write that the p-value is greater than the significance level. So we do not have a significant result, even though the NFL said it was significant. I guess breaking the rules is breaking the rules. So we don't have a significant result, so we're going to reject the ha and be in favor of the original hypothesis, or the null hypothesis. In other words, the footballs, even though they were underweight in pounds per square inch, they weren't at an alarming rate below that 11.42. Again, I'm being very generous with the science behind this. I guess the Pats were accused of cheating. They were penalized, I think, $1 million or something like that. And Tom Brady was suspended for 4 games. And also, they had to surrender a couple draft picks because of it. And I don't even know if it was necessarily because they found the footballs to be underweight. But I think the bigger issue the NFL had was the fact that they were hiding and very secretive about their the way they conduct business. All right, for our second question, we're going to take a look at some of the other chaos from halftime during that game. As it turns out, there were 2 referees that actually did measurements, and they were able to get a hold of also some of the footballs from the opposing team. So you can pause the video or read off of your worksheet to catch up on some of the details before we actually do this. So now that you've read that over, let's discuss our approach on this. So we do have 2 lists of numbers, and because each row is connected to the same football, we could take 2 lists and subtract 1 list from the other to create a third list. And that's very convenient to do. You could say that both of these lists are dependent on each other because they both come from the same football. And that's true for all the footballs on this list, even to the 4th Colt football that's listed here. So the question is, do these referees measure consistently together? By taking a look at these numbers, you might already have an impression that they do not measure consistently. Some of these, these differences here are negative, but even some of them are greatly negative. And when we get to the Colt footballs, oddly enough, some of the differences are positive, which, I don't know, it might give you some suspicion about why these are mismatched the way that they are, especially in a more positive way. So there's different interpretations of what happened during that halftime. But just looking at the numbers here, we can set up our hypothesis test using a t-test once again. So we're going to take both lists, merge them together as I did to create a brand new list. And that can be done on the graphing calculator, as I'll show in a few minutes. But for now, we've got the list by hand, the differences between referee number 1 and referee number 2. Our null hypothesis, when we're trying to do a test like this, usually is that there is no difference between list number 1 and list number 2. So that's going to be our null hypothesis, that the referees do not measure differently over the course of their careers if compared one to the other. The alternative here is that that there is a difference between the way that they measure. So the alternative would be that the mu is not equal to 0. Again, do you see that for this particular, for any of these hypothesis statements, it's always the same number here and here, and those numbers do not come from the sample. It's always an equal sign here, and it's never an equal sign here. Now that we got the hypothesis test started in the right way, we're naming the test. It's a t-test. It would be a z-test if we knew the standard deviation from the population, but we don't know that. This test is also called often a matched t-test because the two lists were matched up and we could create a brand new list from those two lists. So it's okay to call this a matched t-test as well, or just call it the general t-test by the general t-test name. So it is a simple random sample. Nope. Do we have enough in our sample? Well, we've got more than before, but there's only 15 differences on our list. So that wouldn't count as 30 because we're only working with just this list right here. So our sample size is still not greater than or equal to 30. As it turns out, when we take a look at the box and whisker graph, there's some problems here because, there are some problems here because of the fact that there are outliers in our sample. So this is a bigger problem, that the sample size is not bigger than or equal to 30, and also the presence of these 3 outliers here can make our conclusions a little less statistically sound. As for, before I actually get onto the third step, there's still one more thing that I need to do. Do you remember what it is? Something that I say sometimes I occasionally forget to do, and then I have to go back and write one. But it's generally good practice to have a significance level before you figure out your p-value. So in our mind, how low is low? And we're going to go with, again, 5% as being a small amount of probability. So looking at the third step, I said let the calculator help us actually generate our answers. So let me show you how that's done. And I'd encourage you to do this. So to help us with step 3 in our hypothesis test, we could enter the data by pressing stat and edit. In list 1, I've got referee number 1's measurements. List 2, referee number 2. And we're going to, since the data is matched, we can go to list 3 and go to the very top like I did and type in list 1, take away list 2 as a time saver. And that'll give us a brand new list of all the differences there between how referee 1 and referee number 2 measured the footballs. Now from here we can actually use the formulas just as we did before, or we could just rely on the calculator to do the third step for us, which, like again, I would encourage you to do that. So if you press the stat button and press tests, you'll see at the very top there, near the top, is the t-test. And it's already started to, well, it looks like there's already some data there. It already knows that there's 15 in the sample, but those numbers don't look exactly right. It just looks like a number from the last question. In fact, it is. So from this point here, at the bottom of the screen, you can choose between the data, if you have the data available, or the statistics. If you don't have the data, you could actually just type in the information you're given. But on this one here, we're going to change list 1, or list, we're going to change the list to using list number 1. Oops, actually list number 3, since we're talking about the differences between the two. And you can see that it's already calculated for me, at least on the iPad, it's calculated for me the average difference between the two referees and the sample standard deviation. You might have to type, if there's another number on there, you might have to type in the 0 and hit enter. It's very important to hit enter every time you're entering into the iPad, so it will update. So because our null hypothesis was 0, we've actually calculated a t-score, or the calculator has for us very nicely the t-score, and has given us a p-value as well. We do have to make sure that we're using the proper p-value. For examples like the first example, where the alternative was a less than, we would be clicking on that. If the alternative was a greater than, we'd be clicking on that. But in this particular case, the alternative hypothesis was a not equal to sign. So that gives us shading on both sides of the equal sign, or both sides of the t curve. Important to notice that this is not a normal curve. This has a degree of freedom of 14, which looks just like a normal curve. All we need to do is take that information and transfer it over to our paper, which I already did. So the t-score came out to be about -2.5. The p-value includes both parts together. If you did this by hand, you would calculate just one part of it using tcdf. So there's nothing wrong with doing it that way as well, but you would do tcdf from like 2.5 to 1,000 using a degree of freedom of 14. And that would give you probability of 0.013. But because we're dealing with a two-sided test, a miss to the left is just as likely as a miss to the right. You're going to end up doubling the probability together. And that's another way to arrive at your p-value. The last step is to compare that p-value to the significance level. And if you remember, the significance level was 5%. So the p-value is lower than the significance level. And when the p-value is low, you're going to reject the hoe. So in other words, we're going to be in favor of the fact that these referees do not measure consistently. And you can think about maybe the different reasons why that would be true. I've thought about it enough. And, these balls have been brought in from the cold, maybe into a locker room. So maybe they are warming up as part of the problem. Possibly the referees might have an invested interest in who wins and who loses. So maybe they might want to make the Patriots appear to be more of a cheater or less of a cheater as possible. I think also a big difference might be the fact that they might have used different equipment. And maybe what's very likely is the fact that these balls probably got scrambled up quite a bit. So who even knows if they kept track of which ball was which, and how many hands were actually touching these footballs to actually get them to change their weight or their pounds per square inch. So just maybe a quick aside here to get you started with your own work. So you can read these questions on your own, but for those that don't have the worksheet, you can maybe take a screenshot of that. Okay, so in this particular question, the students were given a chance to throw two different footballs, and you can read up more on that as well. I'm just scrolling for people who are in the audience that do not have one of these sheets and are very interested in what questions are following up the NFL questions there. So this is actually a phys ed teacher that compared different throws with different footballs. And, in this particular case, I didn't give you a space to actually subtract one list from the other. But I'm not always going to, in real life, you're not always going to have a teacher that sets up a third column of the differences between the two. But you're just going to have to add on to that list a third list, subtracting one list from the other. And I'll let you work on that. So there's that question there to take a look at. And on the last page, I thought this would be a smart idea is to throw back some other questions that you have encountered in the past and give you a chance to wrestle with that, with those decisions. All right, so to clear that up, in question number 2 for the assignment, I've given you a graphic, and I would like you to take a look at the information that's presented and make some decisions based on what you're seeing. And like it says in bold print here, do not limit yourself to just the topics taught in the second half of the year. So use your knowledge of football in general, perhaps to answer this, but you definitely want to give me some details as well. So don't just give me a sports analysis of it, but actually give me some details. You should be able to plug these numbers into your calculator and in some way give me some information based on what you're seeing there. And you can feel free to use either set of numbers or both sets of numbers. So good luck with that. And hopefully this walkthrough has been effective.